as well as the conditional scheduling, which is basically a huge thing that we're working on with the team, and we wanna give you some more depth insight into that. And yeah, we'll see. We are going to run this webinar together with my teammate Philippe. I'm Peter. I'm Piotr. If you remember my voice. So yeah, let's start. Yeah, we can't basically start without this thing, which is our guys from the team, Daniel and Logan. As you may know, they've been in at the Melon Pour Hackathon in Zug last weekend, and guess what? They actually won the whole thing. They won the grand prize. This is really amazing. So congratulations and kudos to guys, to Daniel and Logan. They actually use the Chronos conditional scheduling, which is even more exciting for us, for the whole team, because that means that we get some precious feedback from the others, from the community as well, on what we're building. So we're really excited about that. And again, kudos to Logan and to Daniel for representing ChronoLogic, as best as they can. Okay, so we're gonna first take around about the Ethereum alarm clock version 1.0 updates and ongoing thing. Then we go into the Chronos protocol with updates and conditional scheduling, and we also going to discuss a little bit more with Philippe. So we didn't really plan this to be a scripted thing. We're gonna a little bit freestyle, and we waiting for questions from you guys. We gladly answer them. So let's go. Ethereum alarm clock 1.0. So as you may know, we are undergoing the audit, the security audit by ZK Labs. So things are going well. We're still waiting for the updates. We in contact with these guys, and as soon as we get anything that we need to fix or something like that, we're gonna do that and then deploy on the mainnet. So I think we're pretty close to the mainnet release. Everyone's, including obviously us, are waiting for that. So yep, still waiting here. Yes, so as you may know, we are working with a 2-week sprints, meaning that we deliver the new version of the DAP, the tooling, and if necessary, the protocol every 2 weeks. So that's when you can expect new exciting things to be added. And this time, last Friday, Anthony deployed the newest version for the DAP and for tooling and all that stuff that we're building on. We call it Pennywise. It does have actually one among the other, but one very exciting feature. We call it TimeBounty Estimation Widget. And this is actually something that was requested by the community weeks ago. We often get those questions. So how big should be the time bounty, to be set in order to get my transaction, executed, right? And our answer is always that this is similar to other how the blockchain works and the Ethereum on Bitcoin. So you put the time bounty that's supposed to be somewhere in the average or above the average. So you are actually above the other transaction, because the logic for the time nodes is that they are going to pick the most profitable transactions, right? So you want to make sure that if you want to make sure that things going to happen at the exact time as you want, or the closest to this designated point, you want to put slightly more bounty. And because we actually did quite a lot of work on the protocol itself, we redesign, re-architect a little bit, and because of that, we are able now to deliver some sort of analytics functions, and I will just show you in a second. Then we have improved caching. So performance for us is basically very important thing. So we want to deliver as fast and streamlined experience to people that are using the DAP and tools and so on and so forth. We obviously updated along the DAP, the command line tools and the libraries and all that stuff. So if you are following our GitHub, you will notice that there is a vast amount of pull request changes and all that stuff. So this thing is basically living, on a high pace. Okay, so let me show you now this timeout estimation widget. So let me know if you basically visited the app chronologic.network. If you've been there, put 2 into the question box. We are really interested, who tried and so on. Okay, I see, nice. So we have some users, great. And so nice, great. So you may already notice that. So how does this work, right? So we are in the scheduling part of the DAP, right? So I just predefine some of the functions, and basically if you go to the bounty tab now, and then you will see what are the time bounties within the time that you want to schedule your transaction. So my transaction, I wanna make it executed at 8 p.m. Today, which means that within the hour, within that time hour, or the hour, we have other transactions that are waiting to be executed, and for from all these transactions, the minimum time bounty is from the other transaction is 0.01 ether, and the maximum is 0.05, right? Which means that the mean value is somewhere like 0.023, which means that perhaps if that's really important transaction for me, I would put something slightly above that, right? So I will put something like 0.03, and then just schedule the transaction. Okay, so deposit, right? If we want to require the deposit from the time node, we need to actually put some value. So yeah, everything rest is just familiar to you, doesn't really change much. If you in general browsing and using and trying with the app chronologic.network, you may notice that the scheduled and completed transaction tabs are blazing fast now. Here kudos to Daniel, who did a tremendous job on reworking and rewriting the whole thing, including the new caching system and so on and so forth. So hopefully that's gonna be really a stable, blazing fast, and really nice and great to use. Okay, going back to the webinar. Let me make this full screen. So besides that, I'm actually working on something that is this is a peak like to what I'm working on now, which is I'm trying to model the economic model, create the economic model for running the time nodes, which is going to answer some questions about whether this is going and when it's going to be profitable, what cost, and so on and so forth. Which means that there is some probabilistic model being built. You can, if you really want, there is some work in progress version on GitHub, Ethereum Alarm Clock GitHub. You will find it on, if you're really interested. This is going to be published soon. It includes some math around that, the model, as well as the simulations. So hopefully that's gonna be useful for you guys as well as for us. So, but that's slightly later. Okay, guys, so going to the Chronos protocol now. So the Chronos protocol, which is a next generation scheduling protocol. This is something that we are working on, and this is our child, so to say. We just adding a lot of changes, improvements, and experiments, and things that we learned when developing the Ethereum alarm clock. So we are super excited about that. Everyone is talking always and all time about the Chronos within the team. So let me again repeat what's the Chronos? So as I said, novel transaction scheduling algorithm. We did over the Ethereum alarm clock, we did a lot of improvements, especially in the cost effectiveness. The gas cost has been pretty much quite a lot decreased. We also started working on and we have something working actually. So the conditional scheduling, so temporal and this conditional scheduling, and improved claiming mechanism. This is another part of the Chronos that we working on. We want to make sure that the efficiency and the cost efficiency economic model is as optimized as possible. So that's also the reason why I'm doing the economic model for the previous protocol, so we can compare and see the differences and improvements and so on and so forth. And the last part is the confidential transactions. This is really a something that we're working on slightly. I started doing some research on how to employ the ZK snarks with the Chronos protocol. We have some first ideas, but this is still, in the research phase. Okay, I see the question from Mr. Swiss. How involved is Piper Miriam? So Piper, as you all know, is the original creator of the Ethereum alarm clock. So the protocol has been created somewhere 2015, if I'm not mistaken. Then it was used and operated, but then it was, for some reasons, it was stopped and nothing really happened. And then that's when the ChronoLogic came in. It was somewhere like November 2017, I think, maybe October. And we basically get a partnership with Piper and start working on the Ethereum alarm clock. Maintaining. We rewrite the whole, maybe not the whole, but we rewrite a good chunk of the Solidity code for the protocol itself, and we redo the JavaScript tooling for it, including the command line tool, the libraries that now we are using with our decentralized applications, and things like ICO starter, which is a very minimal thing just to make the integrations easier. And yeah, so I hope that answers your question. And always, Piper is, the guy that we always working on, chatting with, very, on a regular basis. So he, for instance, over the weekend helped me and peer review the economic model for the Ethereum alarm clock. So he's basically always there, right? So he's involved in many, many steps. Okay, guys. So conditional scheduling. So maybe the question. So actually, I posted the article on our Medium about the conditional scheduling. So does anyone read it and saw it? Just give me 3 into the question box. All right, so I see that. Thank you, guys. If you haven't read that, basically go to our blog, find the article, read it. It's a little bit more detailed, more technical than what we now presenting on the webinar, but basically it is the same thing. You will see a little bit more of the history and story behind why we started working on that, when the whole idea pop-ups and all that stuff. Here we're just going to describe, how does this work and what's the principles. So yeah, we have the conditional scheduling. You guys might ask, what's the difference between the time scheduling and the conditional scheduling, right? And so we said like, hey, we get from the point that time scheduling is just a specific case for the conditional scheduling, because the time-based scheduling is nothing else that creating a condition for a time, daytime timestamp in Solidity or the block, right? So if block is whatever higher or within the range, then anyone is allowed to execute. So we then started thinking on how to bring the integrations to the Ethereum alarm clock. We get we had nice chat with MakerDAO guys among the other teams, and at some point it was clear that we need to introduce something a little bit more complex and a little bit more general in order to handle the cases like stop loss or the CDP stop loss or whatever any other automations that you can think of based on the Ethereum blockchain, right? Because this scheduler works in a way that you put your funds, destination, and conditions. What is the condition, right? You might ask. So condition is a encoded piece or encoded bytes of the execution or basically the execution to the other contract that has to be checked before your transaction is going to be executed. This means that by having that, you can set some conditions like, hey, if let's say the oracle of Ethereum to USD price, and so that price, that pair is like whatever 800 or 10,000, right? Then buy or sell or something like that. And anything basically will work unless it's not going to return you true false. True false is like a Boolean value, right? Which means that if you want to transaction to be executed, you wanna deliver some sort of condition that is going to deliver true or false to the scheduled transaction, which means if this condition is true, so yeah, you are allowed to execute. And the difference with the time scheduling is that, or maybe not the difference, but the thing with the scheduling, you can always test this condition before the execution. So, which means that you don't need to really, your time node doesn't really need to send the transaction blind before knowing whether this is a possible execution that can happen, which obviously is super important in that kind of cases, because you won't lose money on trying to execute something that you know that is not going to succeed. So that's by principle how the scheduled transaction works.
Piotr,
Few
can I
slides.
jump in really quickly?
Oh yeah, Philippe, you're welcome. Hi.
Yeah. Hi everyone. I just wanted to add something. So I know last time some people were asking, and also on Telegram, they were asking, what if my time node goes offline? What happens? Well, now it becomes with time nodes and scheduling transactions that are simply based on time. Let's say I know I'm supposed to execute a transaction at the end of the week, then my time node, ignoring the claiming mechanism and ignoring everything else, but I know when I need to turn off my time node so that I execute the transaction. When it comes to conditional execution, you don't necessarily know when these conditions will be met, which means that you often need to run your time node all the time. And you always need to query the blockchain. You always need to basically watch the blockchain to see if the events that you're looking for a given scheduled conditional execution are met. So it's slightly more involving, but it's very critical that people are watching the blockchain at all time. Time nodes are watching the blockchain at all time for this specific case.
Yes, exactly. Good take, Philippe. So let me repeat that. So basically, since the time is a deterministic, right? So you know when it's going to be like, whatever, in 1 hour, you know when it happens, but you don't really know when a condition for whatever condition that has to be met is going to happen, which means that they can appear anytime, which means that you will be, as Philippe said, asked to run your time node 24/7, obviously that's the most profitable, option for you, right? Because you might miss the executions if you won't be running the time node. Yes, so there is a question from Rafael. How we do that? Be online with a time node all the time? Philippe, would you like to answer?
Sure. The general idea is ideally all the time nodes are always online for various reasons. As Piotr said, it's also it makes sense for time nodes if there's enough jobs out there it's more profitable to stay online as long as you can. But this is not something you will need to do per se. We're going to build clients that will watch the blockchain for you. You're, of course, welcome to write your own script that query the blockchain. But you're basically going to have something that will run on your computer, or you're going to rent a computer on Amazon or DigitalOcean or, whatever servers you want to rent. And you're going to run a script on the computer you have, and you basically just keep the script running for 24 hours or all the time, basically.
Yep, exactly. So we have a couple of more questions. Let's tackle them now. So the other question is, could the time node economics include a melon port token reward if time node is executing stop loss orders for them? So we actually looking into the possibility of having the tokens as a rewards, or in other way to use whatever ERC20 token as a time bounty. We haven't concluded yet, and as for now, the default is Ether. One of the reasons is that, well, I mean, this is like a huge discussion that we can have now. What's better thing for incentivizing the execution, Ether or tokens? One advantage of Ether is that it's obviously the most liquid among the tokens on the Ethereum, and that's why it's gonna be always easy and clear as a reward. Obviously, some of the tokens now are pretty liquid and they have interesting characteristics. Still, if we want to allow people to put like any token, that we might end up with a reward that are with some tokens that people don't want to have, right? For instance, which means that no one is going to execute those transactions, which means that people want, or it's going to be harder for them to understand why and etc. So definitely this is on our timeline on the agenda to look at this. But I think first we'll be using the Ether. I must say that we also considering strongly to use a ERC20 tokens like DAI from MakerDAO, which is a stable coin, which might have different characteristic if you're running the time node. So you basically get rid of the volatility of Ether, and you can predict your income, etc. So that might be the interesting case. But still, DAI is one of the ERC20, so we might basically allow the others, or we solve this in other way that we're thinking of, and I'll explain that a little bit later. Okay, the third question, Philippe, can I run more than one time node?
I think we discussed this briefly last time, but yeah, you can run as many time nodes as you want. By time nodes, I mean like different their address, and then it really matters of how much you're gonna stake when we bring the claiming mechanism and other like staking related mechanism. Then you need to stake an amount per time node, and your chance of winning a transaction, so to speak, or being able to execute a given transaction is going to be proportional to your stake. So what that means is if you stake 10 Ether on one node and 10 Ether on the other node, you're in average you're going to have the same amount of scheduled transaction that if you have a single time node, that's where you stake 20 Ether. Now, where it comes important to have various time nodes is more like a given time node has redundant servers. So you're going to basically use your same Ether address on multiple computers so that if one of your computers fails to execute at a given time, you have backups. But that's something we're going to have like cover plenty in the future of how to make sure that your time nodes are like actually executing the transaction when they were supposed to, so you don't get penalized for, being disconnected by accident.
Yeah, well, I think now that's pretty actually interesting question, because what you said is that it's gonna be on average the same to either run one time node with a 20 ETH, stake, or maybe two with 10 each. But actually, from the network perspective, it would be more beneficial to run two time nodes because they act as a redundant nodes. So I think we need to look at this, again, or renew what we were, discussing before. Just my kind of hot this comment on this.
Right.
Okay.
I see your point of having different time nodes and how it could like increase redundancy. But to me, the redundancy is really about guaranteeing that you're going to execute the transaction when you're supposed to. Therefore, maybe the terminology is where we're getting confused. When I mean time node, I mean one given address. So you could have various clients running the same time node. So you have a computer based in Africa, a computer based in US, a computer based in Asia, and they all running, so to speak, the same time node, or they're all using the stake of the same time node. And in that case, I would say we have one time node that is split into that is distributed, uh, and versus having three independent time nodes that will claim independent transactions and will need to execute transactions that won't be the same. These would be three different time nodes. But yeah, it might be interesting to look at this more in details to see if there's other kind of compromises and that we're probably missing at the moment.
Yeah. So Rafael, actually going with the further questions, I think we move forward now. Rafael, we want to invite you to our, Telegram channel or GitHub channel, or you can reach us, after that. We gladly answer those questions. We just want to, let's see, maybe we just answer them at the end of the webinar. Okay, so yeah, this is just we going back now to the conditional scheduling and how does this work, and etc. As I said, guys, Daniel and Logan use the idea and the Chronos for Melon port, and they build some sort of Melon port adapter. They might call it differently, but basically that's the thing. So it just adapts the Chronos and reduces the whatever the Melon port smart contract returns into true false statements. And you can put in this kind of adapters, other conditions like, whether this is within the range, greater, lower, and etc. This kind of stuff. And this actually goes, brings us to the thinking that probably all the specific smart contracts that we, or people using Chronos would like to tackle are, probably we will need some sort of adapters or small smart contracts that's going to be act as a mediators between, the target, which is, for instance, Ether Delta, MakerDAO, CDP, and the Chronos. And this, what we're thinking, because we are busy with, developing Chronos, we are definitely not able to write all possible adapters, for all possible smart contracts, whatever things people want to use. So we're definitely going to develop a some sort of interface. We also thinking about making this a ERC interface more globally for the Ethereum, because we obviously see a lot of potential in this kind of operations. And I think we pioneering the smart contract automations by employing the Chronos protocol. So and this proven to be really exciting and needed functionality. We get this feedback from Melonport and the others. So it's really exciting. And in general, we're thinking of allowing the community of writing this kind of adapters for Chronos. So we thinking slowly about a marketplace, maybe token curated registry for those smart contracts, etc. But more information will follow up. So this is really something that we brainstorm, within a couple of last days. So just want to show you what's possible, and basically there is no issues for Chronos. Chronos is a very generic protocol. It's gonna handle whatever you put on top of it.
Could you also give some examples regarding how these conditional execution could be useful in like more advanced topics like plasma and state channels?
Yeah, definitely. So, as you may know, we've been in Toronto at EdCon. So Logan was presenting the Ethereum alarm clock and Chronos to the great, Ethereum crowd and the community. We get very warm receipt and super excited by being there. And then I spent some time in L4 Ventures in Toronto with people who are developing the state channels. They're working on what they call counterfactual state channels. And we've been brainstorming the Chronos as a facilitator or a protocol that's going to, do the utility market for just utility functions for the state channels. Basically the state channels is a mechanism that allows people safely, let's say, change the state off chain, which doesn't bring any cost and brings a scalability to the solution. But then there is few places where actually you need to, with a timely manner or the conditional manner, actually act. And what we see is that, I guess, if you are going to use the state channels with some sort of provider, you're not going to do all the stuff manually, right? And this is where Chronos came in. And basically this is perfectly doable to handle the case like a closing the state channel and wrapping up the state, updating the whole state, going with the final state on chain. And yes, this is basically, and then you can see the Chronos as a kind of watcher or the watchtower that's gonna look whether there is a potential challenge or something went wrong with the state channel, someone wanna cheat you, etc. So this is going to be huge and really, we're looking forward for the more of the cooperation. Pretty much the same with the Plasma. So Plasma, yeah, you when you use Plasma, you might want to look at the Plasma chains in case of the problems or the invalidity on the Plasma chain. You want to move your coins to other of the parent or the scandent Plasma chain, and I don't think people are going to do that manually. So you will have two options: either to trust the centralized operator, or you use the market like a Chronos for scheduling and for executions. So that's where we are basically having discussions with people working with Plasma and state channels implementations, and trying to get the feedback and what are the implementation details, etc. So does this answer your question, Philippe?
Yeah, that was great. Thank you.
Okay, so yeah. Okay, this is one of the things that we came out with when developing Chronos and Ethereum alarm clock, and also this kind of pattern was used by Logan and Daniel on the hackathon. And we just want to make sure that our community understands how things needs to work and how things needs to be done, etc. So let me guide you with this a little bit. So by principle, the smart contract who is calling or executing the transaction is then viewed. I mean, the address of the smart contract is then the message sender for the target contract. So if this is a MakerDAO CDP, then even though, so basically it works like that. If you want to operate the CDP, the sender of the message has to be a creator of the message, right? And here we get into a the problem that's because the way the Ethereum works, which means that if you schedule something, um, then the address that is going to be seen by the target, by let's say the MakerDAO CDP, is going to be the address of the scheduled transaction, which might be then refused to be granted a access, right? So we figured a way how to do that. So we wanna, and this is something that we're working on, and we wanna present that to the community via the EIP. And basically we call it a proxy wallet, which is a smart contract that is relaying your it is like your account, right? But the accounts on Ethereum are not able to or execute the code on chain. So this proxy wallet is like your account, but a smart account, or the something like that, a little bit more advanced account, something like a wallet. So we wanna basically pitch this and present the idea to the community, and obviously gonna get some good feedback on that. We're looking forward, but by principle, you will send your transaction via the proxy wallet, which you are owner. Let's say in the case of using the Chronos, you schedule via proxy to Chronos. Chronos deploys transaction, and then your proxy wallet will whitelist the transaction. And then when the time of the execution comes, the destination for this transaction is going to be the proxy wallet that is going to forward to the target, which means that if you create the CDP via the proxy wallet, then if you schedule transaction, do any other automation that is going through that wallet, the CDP will see your proxy wallet. And this is basically not only the problem that we have. If you ever use the multi-sig wallets, that's basically the same. So the same problem. If you have a multi-sig wallet and you want to, let's say, contribute to the ICO, and you whitelisted the other address, not your like a private address, not the multi-sig address, then basically this is the same problem. So we working on that. We use this internally on the hackathon. We know it works. Obviously, need to get into the consensus with the rest of the community. How are we going to handle this kind of issues? Because in general, you can replace Chronos and scheduled transaction with any other third-party smart contract that you authorize to act in your name, basically, right? Okay, so yeah, this is the one of the slides from the hackathon presentation. I just steal it from Logan, and you see now basically a lot of similarity that has been presented here and here. So this is a proof that we really use Chronos, and this very exciting thing that actually wants the hackathon. Okay, so we have a question from Hitch. Is this similar to what you guys alluded to with account abstraction on a lower level on Ethereum? Philippe, wanna talk about that? Wanna take this question?
Yeah, so I'll try to. I'm pretty sure most people are not super familiar with account abstraction, but when we talk about regular accounts on Ethereum, you can think of whatever you're using right now. You can sign messages, you can send your funds, and these accounts basically, in order for you to send funds from this account to another account, the only thing you need to do is sign a message with a nonce, and a nonce is just an incremental value that keeps track how many transactions have you sent so far. Now, when you're using like a smart account, or what they describe as like a proxy, or like a smart contract, basically, that implements some of extra logic, you can say, well, not only you need to assign messages from the owner, you also need to meet all these other conditions, and you can make now your account as complex as you want. It could be a multi-sig. Multi-sig is a good example where multi-signature, you need multiple signatures or multiple addresses before you can send the funds. And what account abstraction allows you to do is everything becomes smart contracts. So even the basic accounts, the accounts that we have on Ethereum right now, you could add additional logic where instead of just verifying did you have the right private key to send a message with the right nonce, or where the right nonce is your current transaction that you should send, so it's my 101 transaction. Instead of having just the signature from the private key and the nonce, you can add additional logic saying multiple signature, different types of nonce. You could have different conditions before you're able to execute. So account abstraction allows us to would allow us to build proxy contracts directly at the like default account level, which might lead to some significant gain in terms of efficiency and gas costs. But that really remains to be seen, because account abstraction is between 1 and 3 years away. It's probably going to come around the same time as sharding, if not a little bit later. Yeah, because it's not backward compatible. There's a lot of stuff that changes. So we're kind of putting this research topic on for our future selves. So in the next, when we get more information on this.
Yeah, exactly. So we talked to the Ethereum Foundation researcher Justin Drake about it. And yeah, unfortunately, that's going, as Philippe said, going to be available in a few years from now. And yeah, we can solve it today. Obviously, slightly less efficient, but on the smart contract level. So we're definitely gonna work on this thing. Okay, guys. So just we slowly wrapping up the webinar, and here I want to basically make clear on what team is working on and what stage are we regarding the Chronos Protocol. So previous webinar we had an amazing and very insightful discussion between Logan and Philippe about the claiming mechanism. We actually have up and running the first proof of concept but for the on-chain implementation for the claiming mechanism. I will repeat that wonderful job by Anthony, aka Adibas03, on optimizing and squeezing as much as possible these the Ethereum VM and Solidity to achieve as low as possible gas costs. And so, and the next stage, that was, again, this is a repetition from the last webinar, is the off-chain claiming mechanism, which is much more advanced and requires much more effort. So this is one of the areas that we researching currently. The second thing is the conditional scheduler, the POC proof of concept, obviously up and running. You will find the Chronos code that has been used on the hackathon on our GitHub. It's open sourced. We definitely looking for a comments and any other feedback. Okay, next stuff is confidential scheduler or confidential transactions. This is still in the research phase. We're working on that, and this is going to be definitely hard to be implemented currently based on Ethereum. And if we look at the ZK snarks, there is a significant cost for a verification. Still, the guys who are working on that are doing the tremendous progress. So hopefully at some point it's going to be really viable to use whatever they're building. And yes, the last thing is the idea of having the scheduler stateless using IPFS or actually we are going to probably abandon the IPFS. We're still working on that because IPFS is a great tool, but actually it does require, I mean, it raises the requirement for running the time node. You will need to be the IPFS node, which is slightly more complicated and put a little bit more, resource, etc. So we're looking into using just events from the Solidity to capture all the code. Should be doable. The proof of concepts are already done, and we're looking forward for that. Okay, guys. So a bunch of links. As I said, we are, visit our page, visit our blog. Recently we just putting a lot of content on our blog, so everyone's welcome to read and comment and obviously like. Our GitHub repos, everything is open sourced. We are not hiding everything. It's really important for us. We love open source. We want people to contribute. So if you feel you have some great ideas, you want to join, you want to help us, the first thing you can do is just to read the whole thing, put the issue to our team saying like, hey guys, this can be done, better, and give us some feedback. We appreciate that. So that's gonna be awesome. Most of you, I guess, are on our Telegram channel. If you are not, join us obviously, and watch the YouTube channel. We publishing a lot of content there as well. So we been doing a lot of interviews with people from the Ethereum space. I find them really interesting. So, hopefully you find them as good as well. Okay, guys, any closing questions? Philippe, maybe you have some questions. We want to discuss something. We missed something. I don't know. Let me know.
I had some remarks. I think it was maybe it's not obvious for everyone like how big conditional execution is going to be. But to me, the scheduling transaction is a small piece compared to conditional execution. Conditional execution brings a whole new market that I think is way bigger than just scheduling transactions. And super excited to see all the collaboration we're going to have with this. I'm really excited to work on conditional execution.
Yeah, so me too. Yeah, I can tell you guys that Felipe joined us because he figured that we're working on that, and he said like, yeah, it's so guys, you're working on the problems that I want to work, right? So he immediately finds us, and now we have a new great team member. Wasn't that the case, Philippe?
Yeah, that was actually the reason I needed conditional execution for some of the projects I was working on. And then I was like, okay, the closest thing is Ethereum alarm clock. Oh, wait a second, this team ChronoLogic is working on Ethereum alarm clock version 2. Oh, wait, they're also working on something that like conditional execution. Why should we just not work together and